So there's a block of mass m1. I'll apply force on the upper block, and as usual the surface is smooth. Later problems will make surface, even the surface also rough. Okay, let this be smooth, and this is rough. We'll assume values like m1 equal to 2 kg, m3 is equal to, let it be 4 kg, mu s 0.5, mu k 0.2. So what is the question that will be asked? Find the maximum force, find maximum value of force F for which no slipping occurs between the blocks, or we can also call this as, or minimum value of force F for which slipping occurs. Are you getting no slipping? I think the word no, I'll bring it nearby. Huh? So I think this is very important. No slipping occurs. Slipping occurs. Try to see that. Maximum value, minimum value. Are you trying to, the same interpretation is same, no? So don't make again mess of this particular data. Maximum force for which no slipping occurs, or what minimum force you should apply so that slipping occurs. What do you mean by slipping? There will be relative motion between the blocks. Getting this one? So in books open, some the same question. Sometimes they ask like this. Sometimes they ask like this. So you should not get confused. Both are same. Okay, now after this, how to get the direction of friction? So it's very sure that they are initially at rest. So when we apply force on the upper block, so then what will happen? First, the upper block will try to move. It will overcome inertia of rest. Whereas what will happen, the block M2 will try to retain the inertia of rest. So definitely the block M2 will oppose the motion of M1. This will be F. And the force will always occur in pair. This will be F. Getting this one? So this will be for no slipping. So for no slipping, what I should do, I'll give one more diagram. This. And this was the force F applied. This is M1. This is a normal contact. Let me show all the things as usual. And this will be normal reaction M2G, and this is N2. Will I agree this? Then the frictional force should act on the upper block like this, on the plank on the lower block in this direction, as we assume condition for no slipping. So both will have same acceleration. Let's write the equations here now. F minus small f equal to m1a. the applied force F minus small f equal to mna. And what is the force that will make the lower block to accelerate? F equal to m2. So F is equal to m1 plus m2 into e. And what is the acceleration equal to? M1 plus m2. Let's substitute the value of a here in this equation. Then how much frictional force will be? F equal to m2f by m1 plus m2 as an increase applied force. As I increase the applied force, what will happen to the friction? Will increase. So therefore, the friction acting, is it static or kinetic? That one, it's a static because there's no relative motion between the surfaces. No need to repeat. No need to repeat, please. I don't have other option to block you from the room. Okay, fine. If anybody adds chorus, this called like a chorus. We are not doing any singing, no, where you can add some content to me. That one. Any doubt? Ask it and keep quiet. Finish over. So as the applied force increases, the friction. Please keep your hand on notebook and pen. Just leave the mobile. Finish over. Leave the mobile. Be away from mobile. Write the content. No, write the content. So how you get a time to unmute, ask everything. So instead focus on the things concept here. Hmm? Adding chorus to me. So look at this. And there's no relative motion, no. So therefore, the friction acting will be static in nature. As I increase the applied force, the friction force will also increase. So therefore, it's a static in nature. Then as I keep on increase applied force, then is there any upper limit for friction? S it's equal to limiting. So I'll go for when F becomes F max. The friction what happen will become FL. F equal to FL. So therefore this will be FL equal to M2 F max by M1 plus M2. So what is the value of this? F max is equal to M1 plus M2 by M2 into FL. Let's try to calculate the value. From here, what is FL? Mu s N1. Mu s is how much? 0.5. This is N1 is how much? N1 equal to M1G. So M1 is 2 into 10. So it should be equal to 10 Newton. So let me get the value of F max. So what is F max is equal to M1 plus M2. M1 is how much? 2. This is M2 value. No? This is 4 and this is M2 is how much? 4 by FL value is how much? 10 Newton. 15 Newton.
Yes, sir.
No, don't repeat again. Mostly the JC double star batch. I can, I'm telling this one, no need of any repeating. If no need of adding any voice to the teacher's content. I'm making clear. Don't provoke me to block you from the class. No need to say yes, no, answers, repeating. Doubt, open your mouth, ask doubt, or else keep your mouth shut. Huh? Especially the JC star batch. I'm getting a headache from your batch. Especially the boys, 5, 6 boys are there. In the beginning of meeting only, I can block you and I'll start the class. Causing big headache for the total everyone. Okay, there's a maximum force for no slipping. Please don't disturb. We have psychologically, it's very problematic. Because on one side we are getting from student methods like I see that no disturbance should be there in the class and you are creating disturbance. It's a very problematic for teacher. Okay, this is a 15 Newton. So there's a force what happen how much equal to 15 Newton is there. Okay, now there's a formula which you have to remember. Finally, this formula is very important. So any force greater than this, slipping will occur. Less than this, no slipping will occur. Okay, already we have discussed previous problems. Similarly, here, I'll keep on increase applied force. Then what will happen to the block? If you apply force greater than F max, then slipping will occur. Directly, let me take the problem. Here in the same situation, let me apply the force. Let it be say like a 20 Newton. Then we have to check it like what were the conditions here. I'm not sure. See, like you don't bother this formula. I'm not sure slipping will occur or not. The same values, huh? For the same values. I'll assume no slipping occurs, and I'll work out the problem. Acceleration equal to F by m1 plus m2. I'll make 24. Calculations will be easier. So 24, 2 plus 4. So this will be 24 by 6, 4 meter per second square. Okay, let's come and calculate the friction. The friction acting, is it a static or different? So we know what is the limiting friction, 10 Newton. So now F equal to m2 into A. What is the value of m2? 4. Acceleration 4, 16 Newton. But what we got here, the friction acting is greater than limiting. So therefore, what is the conclusion now? In fact, slipping occurs between the blocks because the friction value cannot be greater than FL. What is the maximum permitted value of friction? Equal to limiting friction. Anything greater than that, third open, that slipping will occur here. So slipping occur between the blocks. But what we assume, no slipping occurs. So nothing wrong. So every problem you can begin like this. Every problem begin like this. Assume no slipping, then calculate the friction. If it is greater than limiting, slipping occurs. No, if they less than limiting, no slipping occurs. Then we have to change this problem. The problem is now you have to change it. So what we have to do? You have to redraw that. This applied force. Here the friction acting will be kinetic. Fk. This will be Fk. This will be m1, m2. Acceleration a1. This a2. Okay, now calculate separately what is a1. F minus Fk by m1. What is a Fk value? Fk is equal to mu k n1 or mu k m1g. Mu k value 0.2. M1 is how much? 2 into 10, 4 Newton. So substitute this value 24. What we applied is 24 Newton. No? 24 minus 4 by 2. So this will be 10 meter per second. Look at this acceleration. Similarly, what is the acceleration of the lower block? Should be Fk by m2. Fk is how much? 4 by 4. 1 meter per second square. You see that when there's a slipping, the relative acceleration will be non-zero and the friction acting will be kinetic. So this will be the approach for the numericals. When you're doing numericals, no, you're going to develop this approach. So sir, we are very sure that the applied force is greater than F. As if you know formula, okay, but what all this formula is applicable only when there is a friction between the blocks only. If at all, if there is a friction between the ground, then this formula will not be applicable. If there is friction comes, then no longer you can't use this particular formula. If the friction comes between the block M2 and ground, then this formula will not be applicable. So therefore, this is having limitation. Only when there is a friction between the blocks, S, there's a formula you can apply. So instead, I'm asking you to instead what happened, I'm asking you to have a generalized approach. Assume that no slipping, calculate the acceleration of the blocks, calculate the friction acting between the blocks. If the friction is greater than limiting, slipping occurs. Friction less than limiting, then no slipping occurs. Got the idea? There's one basic method. Any doubts you can ask me.
Sir,
Ah,
sir, this problem we did it in two methods now, sir.
what two methods?
In the second method, we assume that there's no friction and then we calculated it now, sir.
Then it was wrong, no?
Yes, sir. Sir, in the first method, I have a doubt, sir.
Ah,
The question was either find the maximum force for which no slipping or minimum force for which slipping occurs, right? For both
ah.
of them, same method, sir. Like, you have to just assume that at F max, friction will be limiting. Like that.
You are English medium or Telugu medium student?
English, sir.
English medium. Then you must understand. What I said, or no, maximum force for no slipping or minimum force for slipping occurs. The meaning is same, no? It's
Okay,
a
sir.
negation. Negation of sentence, you don't know. Negation of sentence. The condition is same, no? Or I said, you can also call in other way. Huh? You have to improve your English. Very, 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 very important. Huh? Okay, now let's take the